All right, so hello again. Today I'm going to talk about what it is to work on the field at sea. And my name is Ludovic Bariteau, and I am an associate scientist working here at NOAA, employed by Ceres, and I'm working with Christopher Ferrell and Jeff Kerr, and you met them earlier in previous presentation. So most of my talk and picture will come from the Ronald H. Brown, which is a NOAA research vessel, and you can see the picture here while it was at sea. And so the topic of today will cover, first I will briefly describe what we're trying to measure, and it's called the eddy covariance fluxes. And then I will show you which tool do we use to capture those fluxes. And then finally I will give you an overview of how it is to work and live on a ship through a slide of some pictures. But first of all, before starting, as some people already asked me, so I'm going to give it a bit of my background. And I originally grew up in southwest France, near a city called Limoges, which is represented here, and Paris is somewhere here. And then, so I went 2 years in the, yeah. So I studied my first year of college in the local university about here. And then after that I moved in the south of France near Marseille, where I got a master's degree in measurement and instrumentation applied to Earth, ocean and atmosphere. And to complete this master degree, I came here in March 2005, and I did my thesis with Christopher Ferrell and Jeff on measurements from ship platform. And since then, for about 4 years now, I've been working here in Boulder. So, and most of my work is on flux measurements from ship platform, and this is what I'm going to talk about now. So first, you probably heard about that term, or maybe not. I'm going to define what is a flux, because this is important for this presentation. I'm going to use this word a lot. So the flux is how much of something moves through an area per unit of time. And this flux depends on how much things are passing through that area, how big is that area, and also how long does it take for those things to go through that area. And as an example, I like the analogy of the little birds, where if you take 100 birds flying through a 1-by-1 window over 1 minute, then you will have a flux of 1 bird per square feet per minute. Now if you expand this window to 10 by 10 feet, then your area becomes 100 square feet, and then your flux is then 1 bird per square feet per minute. So you can see, depending on the area, the number of birds, and the time, the flux will be different. Of course, in our case, we don't measure flux of birds, but we measure different entities like gas concentration, like carbon dioxide, ozone, DMS. We also measure temperature and humidity fluxes, and we don't call that, again, bird fluxes, but we call that eddy covariance fluxes. And what it is, it's the covariance between the vertical wind speed and the entity of interest. So the next slide, I will describe this technique. And so this picture here shows a tower over land. So you have the canopy here, and so you can imagine a horizontal airflow passing by the tower, and then you can decompose that airflow into a sum of numerous different eddies. So some are big, some are very small, they go in every direction, etc. And so an analogy or an example is that when you see someone smoking a cigarette, for instance, you can see the flow here goes straight, and then once it passes a certain speed, we break into eddies. So you can see here some eddies, it's going everywhere, it's turbulent, it's chaotic, it happens different sizes. So this is what we are playing with. So these eddies happen in 3 dimensions, but we mostly look at the vertical component of those eddies. And so, to show you an example of that, if you can relate that to that, let's consider that at time 1, you have an eddy that goes that way, and that moves an air parcel number 1 upward with a velocity W1. Okay, and then at time 2, there's another eddy that goes the other way, and so it moves the air parcel from downward at the velocity W2. So you can imagine that situation happening at one point of the tower, for instance, where we have our instrument. And so each air parcel has different characteristics: gas concentration, temperature, humidity. So if we can measure those characteristics and the up and down measurements and correlate those two signals together, we get what we call the eddy covariance fluxes. So it's the covariance between the motion, the vertical motion, and whatever you want: gas, temperature, humidity, etc. And as an example, we can consider, let's say at that time, this eddy moved, let's say, 3 molecules of carbon dioxide upward, and then the next time, let's say 2 molecules went down. So your net flux will be, over that time, at that point, will be 1 molecules of CO2 upward. So you will have a positive flux, and this is probably what you saw on, I think, Jeff's graph this morning. If we were at sea, and then that will reflect a source of CO2 from the ocean. We'll be measuring something like that. On the other hand, if you can have a source, so the flux will go downward. So with that things, we can look at that. And so as you can see on that diagram here, the fluxes are different sizes. So to measure them, we need instruments that are able to see them. And so we need very accurate sensor. And they also need to be fast, because these eddies go very fast. So we need to capture them in a way. And so this is what I'm going to present you now. What do we use to collect those fluxes? So this picture here is a typical installation of a eddy covariance flux system. And so basically we have a tower. On the top of that tower we have a sonic anemometer, which I will describe a bit later. We have a motion pack to measure the motion of the ship. We have a CO2 water vapor sensor, which I will describe after, and other sensors that I'm not going to talk about here. So first I will start with the sonic anemometer, which is one sensor that we use to measure this up and down movement. And so I brought one here, so you can see it. Yeah. So this is the baby. It's beautiful. So basically the way it works, it has 3 pairs of transducer that you can see here, 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 and here, and here. And then each pair measure a component of the wind. So we want to know the three components, and then we are interested basically in the vertical one. So anyway, the way it works is you have one transducer here that will talk to the other guy on the other side, and then they will talk back to each other like that. They will send a burst of ultrasound, and they will talk like that. And so knowing the length of the path here, we can retrieve the wind speed. So we can retrieve the wind speed here, here, and here. And then by this way, with that sensor, we can measure the up and down movement. So the eddies will go up, we will see it here, and etc. So this is one important instrument that we use, and that is represented here too. There is one issue though on the ship. As you can imagine here, we are on land, so it's pretty cool, it's not moving. On the ship, it's moving everywhere. You have the roll, you have the pitch, the yaw. I mean, the sonic is doing the yaw like that. And so we need to correct for that, to do measurement as if we are on land. And so that's why we have this box below here, which contains some accelerometers and angulometers. And what it does is that it measures the ship motion in the earth frame. So you know how much is your ship moving. And so we combine the sonic data and this motion pack data, and this is represented on that graph here. You have a time series of wind speed, and so the blue is what you get from your sonic. So you can see it has big amplitude, and this is due to the motion of the ship. And so the motion pack, the box here, gives us the red signal here. And so combining the two, we subtract one to the other, and we obtain the green signal, which is the Earth-relative vertical wind speed. So that's one component. So now that we have seen that, we can see how do we measure the characteristic of the air parcel. For instance, the CO2, or water vapor. And so for that purpose, we use what we call a open path carbon dioxide water vapor analyzer. And so this is this guy. It's pretty small and pretty light. And so the way it works, it's based on the absorption of light depending on the gas. So here you have a view of that sensor, and you have an infrared source inside that is reflected to a mirror, passed to some filtering, and then goes to the detector, which is on the top here. And so the way it works is that you have a filter that will change the wavelength of the light source. So basically, it will be a cycle of you will have one light that is absorbed by CO2, then the second light will not be absorbed by CO2, the next light will be absorbed by water vapor, the next light will not be absorbed by water vapor, etc. So by knowing the ratio of the intensity of the beam, you can retrieve the carbon dioxide and water vapor concentration. So this is basically the principle of that little toy here.
Did I hear correctly that it's the vertical that you're trying to...
We can do everything, but mostly we do vertical because you want to see, for instance, how many CO2 goes into the ocean, for instance. So that's why basically we do. But you can do, you could do vertical, horizontal if you want. Like if you want to see, I don't know, a flux from Denver to Boulder, or you can do every direction you want. And so I will come back on other instruments for greenhouse gases later, but first I want to talk about other instruments that we deploy on the ship, and this usually complements the flux measurements that we do. So here we have what we call the sea snake thermometer, and this is just a lovely name for a thermistor that is in the tube here and measure the sea surface temperature. And then we also have some radiation instruments. We have some downward solar and infrared radiation instrument, and this relates a little bit to what Chris Farrell talked about in his presentation, the energy from the sun and everything. So these guys are here for that. We also have other instruments for measuring rain, and they are a little bit based on the same principle as the LICOR, the open path CO2 system. And so the next slide is, I'm not going to go over that table which summarizes the different sampling rate and how fast the instruments are working, but I want you to see how it looks like when it's deployed on the ship. And so basically we have on the Rembrandt, we have a tower which is about 18 meters above the water. And so we set up our sonic that you just saw before, the LICOR here, we have a couple of them. And we have other instruments, we'll talk a little bit later. And so we usually put them here to avoid any contamination from the ship. You don't want to put them behind the exhaust pipe or something like that. And you don't want to put them behind the ship so the flow is distorted. So you have a lot of things to take into consideration, and that's why they're located up there. You can recognize here the radiation sensors that are away from any shadow. And so anyway, this is how it looks like on the ship, on the Rembrandt. And here, we also sometimes use other instruments to measure cloud properties, and you're going to see one after, which is the LiDAR. And so I'm not going to talk too much about that, but basically this is just to show you how crowded the ship can be with instruments. For instance, sometimes we bring a van and we put different sensors on the top. Again, you can recognize the radiometer here. So basically, these instruments tell you how high are the clouds, what is the liquid content into the atmosphere, etc. So now I'm going to show you just some example of what we get out of these sensors, and I'm not going to go too much into details, but from top to bottom, we have a wind speed time series and wind direction, so this we get from the sonic. We also have air temperature and sea surface temperature, which is in red. We can get a time series of the solar and infrared radiation, relative humidity, and barometric pressure. So this is kind of the meteorological data that we get on the ship, and then along with that we get the eddy covariance fluxes. Here it's not gas, but it's just humidity and temperature. We have the stress, which is another flux, but it's just the covariance between the vertical wind speed and the horizontal. So it's like it gives you the force given by the wind on the sea surface. So this is what's represented here. And we also have the latent and sensible heat flux, which are linked to temperature and humidity. We have the solar and infrared radiation. And so adding all of that together, we get the net heat flux, which is the amount of energy the ocean gets from the atmosphere and the sun especially. So this is just to give you some time series example. And so here is similar to what you're going to see with the LiDAR. It's a bit different, but this sensor is could have been useful when we were outside to tell you how high were the clouds. For instance, on that 24-hour time series, we can see that there was a cloud here around around noon UTC, and so that tells us, okay, the amount of clouds in the atmosphere and stuff like that. I'm not going to talk about the other graph on the right. And so these are an example of what we can get after launching about 100 radiosondes during a cruise. When we combine all of the profile together and put them on a nice frame, we get kind of a profile of the atmosphere, and we can see the different layers, different boundary layers. So you can see there's a layer here, there's something happening here. Here it was the Saharan dust coming from Africa. Here we can see some convection happening near the equator. Anyway, so this is just to give you an example of what we can get from these radiosones that we just launched. Back to some greenhouse gases. I have been involved over these 4 years on a project that measures ozone fluxes, which is kind of pretty recent at sea. And so the ozone, if you remember, there is a good and a bad ozone. So the good ozone is the one that is up in the stratosphere, and it's this ozone layer that protects us from the harmful ultraviolet, sun radiation. And so this one is good. But there is also some bad ozone here in pollution in the city, so it's pretty bad for your lungs. And so people now like to know the budget of ozone, how it is created, transported, and destroyed. And so we know that over the ocean there is a downward flux of ozone. So the ozone is deposited into the ocean. And so because of that, we say, okay, we're going to go at sea and measure those fluxes. And so I'm going to show you what we did to do that. And so this is a different sensor than this little guy. I mean, as you can imagine, we cannot put this big gray box up in the mast. It's too big. So what we do is that we put it in another place on the ship. And so this is what you can see. This is the instrument here. It's myself and Jack, the engineer that worked on that instrument. And so the way that instrument works is that because we cannot be on the top, we deploy an inlet at the top of the mast, and it goes through a line. I will show you a picture after. And then it goes to a cell measurement. And through that cell, we inject some nitric oxide. And so when those two guys meet together, bam! Oh. This is pretty good. Okay. So this is the ozone here, 3 molecules of oxygen, and this is the nitric oxide. And when they meet, there is a light emission. So every time they meet together, there is light, like that. And so what we do, we use a sensor to detect that light, and we count the light emission. So like a flashlight. And we are like looking and we say, okay, 1, 2, 3, 4. And so this is how we retrieve the ozone information. And so again, using the sonic and that, we get the ozone fluxes. So here's a picture during a deployment on the Round Brown in 2006. On the top, you probably recognize the sonic, and we had an inlet that was going all the way somewhere here, where the Graybox was, the instrument. And so the line is about 30 meters. So you imagine we have to set pretty hard in that line, and even though we do that, there's still some delay between the sonic and the ozone instrument. What I mean is that the sonic is open and it captures the eddy right away. But the time it takes for the ozone to go through that tube takes a bit more time, so we have to think about that and take that into consideration when we do that.
That's collecting ozone at the surface?
This is collecting the ozone at 18 meters.
Right, but that's not the ozone way up there.
No, that's the ozone.
So where's that ozone coming from if you're out in the middle of the ocean?
So mostly it's at the top of the boundary layer. There's some ozone that is there's an entrainment layer, and so you have these giant eddies that brings this ozone between the troposphere and stratosphere and bring it down to near the surface. I forgot if it's between the troposphere and the stratosphere or at the top of the boundary layer.
Top of the boundary layer.
Yeah.
But that ozone comes from
the stratosphere.
That ozone is a byproduct of the things that we do as industrial and.
But is it coming off in North America, basically?
Every continent, and it's globally distributed.
When you say boundary layer, are you saying there's a boundary where the ozone up in the high water stratosphere is not mixing down below?
That ozone does not mix down.
Okay, so the boundary is what we're producing and what's natural.
The boundary layer, the atmospheric boundary layer is about 1,000 meters deep.
Okay.
Approximately.
So what we measure is just the deposition from the top to the ocean because of these big eddies. So again, here's another view of the system, the Graybox, the instrument, and here are the pumps that suck and pull the air through that line. Let's see. So now inside that Graybox, we pull the air through that tube. It goes here, and it goes through that set measurement right here. And so we have our little instrumentation and acquisition system. And so this is how it looks like inside the Graybox. It looks like a little bit messy, but if in the lab when this project started, it was even more messy in the way that the sensor that you see in the Graybox was like that. It's just a bunch of wires and connectors. So over the 5 years, this has been well improved. And
so do you build all of these here?
Yeah, we build that with Instar, which is a laboratory on the East Campus of the university. So the engineer I showed you before built that sensor, and I did some tests on it with him. So it was local boulder building. And so far we have been able to deploy that instrument on 5 different cruises that you can see on that map. Pacific Ocean, Atlantic Ocean, and along the Gulf of Mexico, right here. And so far it has been pretty good. We've been able to retrieve the ozone fluxes, and so now we have to look more about how the different conditions at sea will impact those fluxes. So this is a project going on, and I think it's pretty interesting. So now the part that you want to see, some pictures of how is life at sea. And to give you an overview of that, I selected a cruise I went on last year, which is represented here. So we left Montevideo in Chile, went to that zone here very close to South Georgia Island, and then went back to Uruguay after 45 days at sea. And at the same time, so this was in the southern hemisphere, and at the same time, one of my coworkers, Dan Wolf, went to the northern hemisphere to do chemistry near the Arctic. So these pictures will show you kind of an inter-comparison between the two ships, how is life on those ships, what did we do, etc. So this is the Nord, the ship that my coworker went on. And so again, you can recognize some of the instrumentation. This is to measure the fluxes, cloud properties, and then you can see the balloon that you just saw an hour ago. So here we go. The next slide is the Round Brown, the one I've been on most of the time. And so here you can recognize the ozone instruments. There was also a DMS instrument on the back, as well as some carbon dioxide here on the top of the mast. A lot of sonic to make sure we had our data collected, because this cruise was pretty windy and there were a lot of waves, so you don't have time to go up in the mast at 18 meters and have time to change and fix the instrument. So that's why we had a lot up there. So when I first started to work on the round brown, I thought the ship was pretty big, but after seeing a cruise ship close to it, I was a little bit disappointed. That's a cute little picture. All right, so see here I was just comparing the room where you sleep between the two ships, and so usually you share the room between with 1 and 2 persons. So you can see here there were 3. I was in that room. I was sitting here actually, and so my coworker had a bunk here, and he was sharing a room with someone. And as you can see, sometimes the beds are not very high. I mean, you have this little book here, maybe too high, and he was sleeping here. So that's pretty fun. And so that's for sleeping. And so we also have sometimes some workout room. And so the one we had on the brown looked a bit more modern and nicer than the one they had. Here, this one looks a bit rusty. So just some fun comparison. Now, of course, the food. At the beginning, it's good and fresh, and after 40 days, it's not exactly the same, but you survive. So here is just a picture of the kitchen on the round brown, and here we had about 2-3 dishes of choice every day. And so here's the kitchen. Same thing for the NOAA. I think my dad didn't have a picture of the kitchen, but they had some goodies for the afternoon, and we did not. So I was a bit jealous. And this is the kitchen on the NOAA. And so the schedule on the brown is a bit weird, because the breakfast is between 7 to 8 in the morning, and then you have lunch at 11 to 12, and then I think dinner between 4:30 and 5:30. So it's pretty close together because it allows the crew to work and have a normal schedule. But it takes time to get used to that at the beginning. I have difficulties with that. But 3 hours after breakfast, you have lunch. So that's.
Is alcohol allowed?
No, unfortunately. I wish I had some wine for my dinner, but I don't. So.
Well, having been to Prudhoe Bay, and it's not allowed there,
yeah.
You know, that's a private company. It's because of the safety of the work. I just wondered if that was the case.
Yeah. Yeah, officially it's not allowed. But it's funny, every time I go on the ship and people say they discover I'm French and they tell me the story. Oh yeah, I've been to this French ship where they have a pastry and a boulangerie and wine. And some ship they have more a nicer kitchen and stuff. But anyway, so here this is. I think Dan was either here. He was working on the tower, fixing a box that was broken, and you will see in a couple of slides later why. And so there were 3 working here. Here they were deploying the sea snake that measures the sea surface temperatures. And here just a picture of once at the beginning of the cruise you have to try your survival suit. In case there is a problem, you have to go into the water. You try those beautiful red suits. On the round brown, meanwhile, I was by myself cleaning the radiation sensor here, and you can recognize the tower on the back. Here, I was deploying the sea snake, and same thing, we're trying those survival suits. So similar situation here. And so now, more fun pictures. This is just to give you an overview on the round brown and the cruise I went on of how messy a lab can be when there are a lot of scientists putting their sensors, so it's everywhere. And so we had a little table with other co-workers from different institutions to look at the data every day. We go out, we check our instruments, we collect the data, we look at them, and we make sure everything is okay. So this is kind of the routine that we do every day. We also do once in a while some laundry. We have a laundry room, and there's also a place we can watch TV at night and some movies and stuff. So it's not so boring. There's some fun stuff to do. So here was some activities that we did during the cruise. Sometimes when the weather is okay and the waves are not too big, you can climb the mast when you have some problems. So this is what this picture shows here. And here are other people working on a CTD, some CTD samples. So basically they drop that thing in the ocean, sample at different depth, and then they are here collecting the sample to analyze and see how it was. So this is a picture.
That was water in the bottles.
They were, yeah,
So
seawater.
the bottles are open, and then they close them as they drop it down deep, and then they close one individually at each depth that they're interested in. They bring it to the surface, and then each of those investigators that were huddled around there, they've got a little beaker or something that they fill with water, a prescribed amount of water, and then they take it. They either put it in a box and seal it up, put it in a box to bring home to analyze for chemical species, or they have an analyzer right there that they run the samples through, and they're looking at whatever they're interested in. It could be carbon dioxide dissolved in the water. It could be other species. Could be iron, dissolved iron, or other heavy metals.
They look also at temperature and salinity and these kind of things.
You called it an acronym. What was the name of it again?
Oh,
It's not a real question.
yeah, it's I forgot. It's a good question.
Conductivity, temperature,
Density.
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 So you get the salinity and the temperature. The bottles themselves, the whole thing is called a CTD, but it's not really. There's a rosette of sampling bottles, and in the center of it, at the bottom is the temperature and salinity instrument.
Yeah. So this is just the bar, the NOAA where Dan went, my coworker, and you can see now why they had to work on that mast, because the wave were breaking on it, and they did some damage on some boxes, and the intensity of the waves is so hard sometimes that it breaks everything. So usually we try to put everything on the top, but sometimes it's not possible. Now my cruise, I had some nice weather as well, like you can see. We had a beautiful storm before on the way back to Uruguay, and so you can see the bow of the ship hitting those waves, and you can see it splashing. And here it's good to see if you like to be at sea or not. If you get seasick or not. You won't get that anytime, that's okay. And here the same thing, but from the fantail, the back of the ship, and you can see the height of the waves passing by and splashing. And yeah, I don't remember if I was outside to take a fresh air breathe or it was just for the pictures. But yeah, I remember we got shagged. I remember working on my computer, and then we got raw, and I had to go back. And that was a lot of fun. So here again is the same thing. Here a little bit with more winds. And here is just some pictures when we departed for the cruise. This was in Punta Arenas, Chile. So usually before leaving we try to do a little tour of the surrounding. And so this was a pretty nice place. We had some nice mountains, as nice as here in Boulder. And there was a lake here. And so there's always some local market with fruit and fish and stuff, and then you have also some curious little animals. Also in that city, I remember there was a big colony of penguins, so as you can see here, it's pretty huge. And just some other picture. This picture is just, I think, a sunset while we're at sea. So this is another thing, if you like to watch sunset and sunrise, go on the ship. And so here is just kind of the succession of when we departed. We always have this pilot boat that kind of push the round away and guide it away at sea, and then this is when we were departing, so you can see the land going away and away and away, and then you are at sea. And in that case, in that cruise, it was very hazy, and it was kind of sad. Usually it's good when you have sun, you can go out and enjoy, it's good for the spirit, but here it was no sun. And so here, this is just a fun picture of the CTD that was dropped on the deck and got broken. So sometimes there is accident that can happen. And luckily, nobody was below that thing, otherwise it would have been pretty bad. Here are just other pictures of activities going on the ship. Here they were deploying an instrument, and I forgot the name, but it's just to do some seesaw. They do sample in the ocean of, is it kind of a radar or something? sonar.
Well, I don't know what they're doing there, but
Yeah.
there's lots of different things
Yeah.
that are deployed on there. But it works like a glider. It's towed behind the ship. You can make it go to different depths.
So it didn't go very well because I think they did a test, and so this black cable was in the water very far away, and I don't know if we hit a whale or something, and so this the cable was damaged, and we had some issues with that. So maybe a big fish went after that. It's like thought it was something to eat. Anyway, and so here maybe Jeff showed that to you earlier. They were retrieving or deploying a buoy, and they were putting this big drifter here below it. So this is a nice picture of that. And here's just a picture of scientists watching a sunset here. During that cruise here in the Southern Ocean, on the one I went on, we were close to South Georgia Island, so we were able to see more mountains. And then we also saw some icebergs, which was pretty nice. We had a snowstorm event, which was the first time, except in Boulder and in France, I saw snow. I mean, at sea it was pretty cool. And here's just another picture of the sunrise. Oops. And so, of course, one great thing when you go at sea too is to see nice wildlife. And so we can see, in that cruise we saw penguins, some albatross, this is a dolphin, some birds that were interesting by some instruments. So they thought it was something to eat. Unfortunately, it was not. You had a question?
I'm just wondering, I'm not sure I've seen any women in any of these pictures. Are there?
Well, we explain later.
That will be next one.
Yeah, are you the only,
I
are you
don't
the
know how
only
many,
woman on ship?
I don't know. I have no
Wow.
idea.
So the question was?
Well, I'm just observing that I haven't seen any women so far in the photos.
Oh, I can show a picture of a woman. But
No, one that was on the ship.
Not those
But yeah, no, they are women. Actually, on that cruise, they were about, I would say it was not too much, 4 women. And because I remember they had a dance party, so there was like some women dancing, some guys. Yeah.
I mean, do you take a nurse or doctor or anything?
There is kind of a nurse, a doctor, but usually it's not advised to get sick. I mean, this is to tell you how good is the doctor, I think. But he knows, for instance, if you have some little problem, if it gets too bad, usually you have to go back to land. I mean,
The whole ship?
yeah, I mean, it depends what happened. You know.
Yeah.
If you're just seasick, that's okay.
Yeah.
I would assume that's a big problem, because
Well, some people have been, I know people have been spending like 1 or 2 weeks at sea the whole time seasick. And there is no way the ship is going to go back just for them, just for that.
yeah.
I mean,
unless they get severely dehydrated.
yeah. Yeah.
So how many people total are on the ship?
Six,
Yeah, without the crew, right?
And 4 women?
including the cruise, about 60 on the
So,
ground.
I think we had a bit more on that ship though,
Yeah,
because this was a very crowded ship and there was a lot of scientists, a lot of crew members and stuff like that.
So is there like a director of all the scientists that,
Yes, there's a chief
Sort of,
scientist. Yeah.
yeah.
On this cruise there were 2 actually, and so they coordinate all of the activities and they say where the ship is going for that purpose and etc. Yep.
And then did you get to rotate jobs? I see that you're doing the sea snake and you're cleaning, so you kind of get assigned a job for the day type thing? Or?
Yeah, you try to have a routine. And basically, once you get up, you take a breakfast, you go check your instrument, go look at some data. On the ship we have internet access, so on that cruise actually I was holding a blog on the series website, and so I was able to post some stuff on it. And so every day you try to have a routine to remember what to do, and secure the data in a place that you don't want to lose them and stuff like that. Yeah, and also clean the instruments because a lot of sea salt is going on them, like the radiation. So you have to make sure you wash them and some stuff like that. Yep.
So, like, for something like that, did you or whoever just say, oh, I kind of want to measure this, and tell someone to build it? Or do you?
No, This it's a company that makes them, so I don't know how it's originated at the beginning. I think it's kind of, I don't know, my guess would be that, you know, there's a lot of different instruments to measure wind speed and direction, and the traditional one are just a probe vane, so they have this little wheel and the direction, so but sometimes they're not strong enough, and so those ones are, you know, strong and they can measure, and they are more accurate too. So it's just evolution of instrumentation. You know, you start with a crappy old thing, and then you end up with that pretty good thing. So to end up here, I could show you what happened to me in 2005 on my first cruise. So basically, there is a ceremony where when you cross the equator for the first time, before that you are called a polywog, and after that, after being initiated, you are a shellback, which as I just looked means you become the son, one of the son of Poseidon, the king of the sea. So I'm not going to show everything here in case you had to go one day. So, but I'm going to show you some of the activities we had. And so it's too fast. Okay. So basically here we cross the equator. Oh, that's fast. How can I stop?
When you're locked up with these guys
I
for
can
45 days.
Yeah, but it's going automatically. I don't know how to stop it.
So what? Is it
Yeah, there are
So what's a log?
Polywog.
I want to stop that slideshow. Hopefully it works. So okay, so I would just go like that. When you cross the equator, some people take care of you on the bow of the ship and wet your clothes. Anyway, I will let you look at the picture and talk about it after. That would be better. So here we had a beauty contest. The guys had to be like ladies.
They're getting desperate.
The ladies had to be like guys. Vice versa. And so when this happens, then there is a judging ceremony.
Is that George?
And so here you get a nice haircut and shampoo. You get your ass put in a bucket of cold water and ice. And that was cold. You see here you get judged. You say, okay, I was guilty. Blah, blah. You get on a fake electrical chair. You pass through a tunnel of dirt and garbage. And then finally you have to kiss the feet of the queen of Poseidon. So there is peanut butter and some other things on it. And I didn't know that too much before, so I didn't like it much.
This is nothing compared to the way it was in
Yeah.
the old days or the way it is in the navies. This is really, really tame.
So at the end they wash you and you're pretty cold. So
You didn't know this going into it, or you did know that was going to happen?
You
Yeah.
don't know exactly what's going to happen.
Yeah, you
but
don't know.
It's gonna,
That's why I can
So
assure
they
everything
design it
about-
every year a little differently.
Yeah, but it's kind
They
of.
tell you wear old clothes. So
Yeah. And you have to wear
Have
your
you heard
clothes
this before?
outside,
I had
inside
not heard
out.
this before. This is the
This
first
kind of
I'm hearing.
thing.
This is the
Oh, really?
first?
So
When you're
we're
not
not
gonna
crossing
cross
the equator, so I'm good.
Look for it on a future cruise.
Can you
I
lie?
have the feeling though.
Well, what if you would cross the equator but not on a ship?
That's
then,
don't
then it does.
Then you're good.
Yeah, it's
This is
not
all-
Navy tradition.
This is
so-
all has to do with what Poseidon wants. And Davy Jones.
Davy
So
Jones.
if you don't have to accede to their demands, then
So like that huge ship your friend was on, is it an old cruise ship or was it made specifically?
No, that was, it was in the background.
That was the ship.
Yeah, that
Did
was
you
the
see
ship
it?
there.
It was in the
Yeah.
background.
That was the comparison.
Show us that picture.
Yep.
Of the, there was the big blue ship.
Just look in the photograph.
Oh,
Yeah.
I missed
You
that.
see how small it is.
Yeah, because I wasn't feeling a bit sorry for him when I saw
Yeah.
that at first.
How do you feel about map of feet?
Right there.
The brown is,
So the
the
brown
brown
is
is,
right here.
Now,
the brown is 280,
I got you.
280 feet long.
You can't see it, yeah. Like I said, it looked like they were like cruise
Yeah.
ships. Jeff, what was that built on, Brown?
96.
And the NOAA was 69, so.
They're very similar. I mean,
Yeah.
you wouldn't, there's not that much difference. A brand new ship is not,
Looks the same.
doesn't feel any different than a 20-year-old ship.
So I think that's it for today, so I don't know if you have questions. Or
I
more
think we need
questions.
to get over to Roll, we were supposed to be.
Okay, yeah, we're a bit late, so.
Thank
All
you.
right.
Thank you.
Thank you.
Just real quick, how many times a year do you go to sea?